All right, so today we're talking about multiplying, dividing, and simplifying rational expressions. And we're also going to talk about the domain or domain restrictions. So I'm just going to start you off with a really simple example. If I had asked you to simplify the fraction 2 plus 1 over 2, I would hope we know that there's kind of an, unwritten rule that you can think of there as being parentheses around the top and bottom. We need to simplify the top and bottom before we do or perform the division. So in this case, of course, we would need to add 2 plus 1, which is 3, over 2. Or, of course, if we actually divide that out to a decimal form, we get 1.5, right? So hopefully we know we have to perform those addition or subtraction, anything in the top and bottom. Thinking about order of operations, there's those invisible parentheses, and you have to simplify in the parentheses first. Okay, so I would assume most people know that you can't do this, that you cannot cancel out these 2's in the top and bottom and say the answer is 1. Obviously, that is not equivalent to the true answer. So I would assume most students would know not to do that. Okay. However, very commonly, we'll see students do something very similar like this. Okay, we cannot cancel these x's out in the same way that we can't cancel these 2's out. There's an operation that has to be performed up top first, and that may not have a common factor with x. Okay, so that's why we cannot cancel these out. This is bad. Don't do this. You make kittens cry when you do that. Okay, so don't do that. The only things we can cancel are common factors between the top and bottom. In the same way that most of you would know, we can cancel out 6/4 or reduce it to 3/2, because if we were to break them into their prime factors, we can cancel out the common factor of 2. Okay, so we can only cancel out common factors from the top and bottom of a rational expression. And factors are numbers, expressions, or quantities that are held with multiplication only. So if there's still adding or subtracting going on and we can't match an entire expression, we cannot cancel things out or simplify it. Okay, so here's some steps we're going to use, and these will be repeated on the next pages. But the first thing we want to do with these rational expressions is factor the top and bottom completely. Okay, if you cannot factor them, place parentheses around any non-factorable expressions. So for instance, x plus 1 up here, in this example, I would have wanted to put parentheses around and thought of that's its own factor. X plus 1 is a factor, x is a factor, they do not match, we cannot cancel them. Okay, the next thing we do is state the domain. So hopefully you guys know there's only a few things you can't do in math, and one of them is you cannot divide by 0. You cannot have 0 in the denominator. If there's a 0 in the denominator, this is undefined. Okay, so specifically, if we were looking at, say, this expression, what would make the denominator 0? When x is 0. So your domain for this would be x can't equal 0. Okay, it could be any other number, but plugging in 0 makes the bottom 0, and our whole expression is undefined. You cannot divide by 0. So that's what it says, excludes any values that give division by 0. Okay, but once we've factored it out, we can cancel like terms or quantities between the top and bottom at a 1-to-1 ratio. Do not cancel terms over addition or subtraction. In other words, do not cancel those x's out, just like you would not cancel those 2's out. Okay, so let's take a look. I just have these steps up here again, but let's simplify each of these and state the domain. So again, step 1, factor completely. And remember, when you're factoring, the first thing you always look for is there a greatest common factor? And up top, yep, as I look in here, these both have a common factor of 9 and x. So we're going to factor out our 9 and x, and divide that out of each of these up top. Dividing it out of this term leaves me with x. Dividing it out of this term leaves me with positive 1. Okay, so the top becomes 9x over x plus 1. The bottom has a common factor of 2. So we're going to factor out our 2. Dividing it out of each of these leaves me with x plus 1. Now notice, we just went from things that were held with addition to now we have expressions that are held with multiplication. And that's what's going to allow us to look for common factors or simplify this. And in fact, we do have a common expression, x plus 1, that we're going to be able to get rid of. Before we get rid of it, though, we want to state the domain. So for our domain, what value or values of our variable would make the denominator equal 0? Well, in this case, this doesn't even have an x with it. That will never equal 0. That will always equal 2, so we don't have to worry about that. But when does this expression equal 0? Well, of course, we can take that off to the side and say, when does that equal 0? And that's when x equals -1. So our domain is all real numbers as long as x does not equal -1. Now, you don't have to write it in this specific form. You can just say x can't equal -1, and we'll accept that for your domain. Okay, this is the all real number symbol, and this bar, this big vertical bar, just means such that. It's like a condition. Okay, but finish simplifying. Yes, we can cancel out this common expression. For any value of x you plug in here, the top and bottom will have a matching factor. So we can cancel those out. However, you have to keep the domain of the original expression where they are not equivalent. So even though we're going to simplify this to 9x over 2, we still have to keep the domain that x cannot equal -1. Okay, if we didn't keep that domain, this expression is not technically equivalent to that expression. So it's really important to keep the domain of the original function. Okay, let's try our next example. I can see we've got some quadratics. We have lots of things with addition or subtraction in the top and bottom. Now remember, again, you cannot do that. Please don't do that. There's addition or subtraction. There's lots of operations that would need to happen in the top and bottom first before we can do that division. So we need to factor these. And yes, they are both quadratics, and I believe they're both factorable. The two numbers that multiply to 6 and add up to +5 are 2 and 3. X plus 2, x plus 3. Nice, easy factorable one to start. In the denominator, we need two numbers that multiply to -33, so they're opposite signs. And they need to add up to -8, which means the bigger number is negative. And I'm going to say that's -11 and +3. Just double checking, they do multiply to -33 and add up to -8. Perfect. Okay, before we look for anything to cancel out, we want to state our domain. And it's going to be easier to see what value or values of x make the denominator 0. So off to the side, we're just going to take each factor. What makes that equal 0? So what makes x minus 11 equal 0 when x is +11? And what makes this factor 0? What makes x plus 3 equal 0 when x is -3? So for our domain, we can say it's all real numbers as long as x does not equal -3 or +11. Any other value is fine. Making the numerator 0 is fine. 0 over anything is 0. Except for 0 over 0, which is undefined, but probably won't run into that one. Okay, so then we look for common factors. Again, we have things held with multiplication, and I can see we do have matching expressions we can get rid of. So we can simplify this to x plus 2 over x minus 11 as long as we keep that domain. So remember, this is not equivalent to the original if we didn't keep the domain of the original. Okay, yes, so now in the simplified version, it looks like x only can't be +11. But again, it is not equivalent to the original if you change the domain. Okay, so we have to keep that restricted value. All right, let's try our next one here. So again, we want to factor as completely as possible. And up at the top, hopefully we remember our difference of squares. X plus 3, x minus 3, pretty common one. Now down below, we might notice that this looks very close to a factor we have up top, but it doesn't quite match. So what do you think we can do to instead make this a positive x? What could I take out as a common factor that would make it change its signs? We can take out a -1. And if we do that, that makes our x positive, and I'll put it in front just to match the form up top, but that would also make our 3 negative. Right? Dividing each of these by -1 would just change each of their signs, and now we can see we will have some common factors to get rid of. Okay, but our domain, what would make the denominator 0? Well, -1 will never be 0, but this expression could be 0. When does x minus 3 equal 0? When x is positive 3. So for my domain, x could be any number except for positive 3. And don't forget to put this slash. If you wrote x equals 3, then you're saying that's the only value you can equal, and in fact it is the exact opposite. It's the only value it cannot equal. Lastly, can we simplify our expression? Yep. We can get rid of the x minus 3's in the top and bottom, right? These quantities held by multiplication. So that gives me x plus 3 all over -1. Now, when you just have a -1 or positive 1 in the bottom, we don't need a fraction anymore. But we do need to multiply the top and bottom by -1 to get rid of the fraction, right? This would give me a positive 1 in the denominator, so no fraction needed. And we can go ahead and distribute the -1 here to make it -x minus 3. So this last part was really just simplifying it down so that we no longer needed a fraction, just applying that -1 to both terms in the top. We're multiplying top and bottom by -1 to get rid of it. And remember to keep the domain of the original. Even though there's no denominator here, x still cannot equal 3, or it's not equivalent to the original.